Hello everyone. Welcome back to Discrete Mathematics and its applications. We solve this exercise. We want to find the transitive closure of R, where R is the relation on natural numbers, where A comma B is in R if and only if B is actually equal to A plus 1. So what is the transitive closure of R? It would be uh, helpful. It may be helpful just to draw or to draw examples, to draw the instances, the graph of R, so with some instances of the domain. So let's say this is natural number, so we start with, let's say we have 0 must be related to 1, right, by R. So all arrows here are R, right? So, and this is the only way. From 0 you only go to 1, right? You don't go to another number. How about from 1 you go to 2, 2 you go to, well, 3, and in fact you have this. And what about the transitive closure? We want to make sure that the all the two hops are connected by a shortcut, right? So therefore, for example, you have this, must have this, you must have this. Say if 4, let's just extend the sequence. So you must have this, must have this, you must have this, and you must have this, you must have this, and so on, right? Now, because now we have a shortcut from 0 to 2, for example, then you must have a shortcut 0 to 3. Also, similarly from 1 to 4, 2 to 5, right? 3 to 6, 4 to 7, 5 to 8, and so on, right? And so on. Now, similarly, because you have a relation from 0 to 3, then you must have 0 to 4, 1 to 5, 2 to 6, 3 to 7, and so on, right? So essentially you always add shortcuts. Yeah. So for example, in R2 you have, uh, because you have a direct relation, you have a connection from 0 to 1 and 1 to 2, so you shortcut it, right? You get 0 to 2. Now because you have a shortcut, so you add another shortcut, and so on. So you could see that actually eventually, for example, 0 will be connected to all natural numbers above it. There are ledger to it, right? So that means, uh, if this is the transitive closure of R, then example 0 1, 0 to 2, 0 to 3, and so on are in the transitive closure of R, right? You also know that, uh, 1 to 2, 1 to 3, 1 to 4 must be in transitive closure of R, because you always add shortcuts, right, to the next larger number, and so on, right? So 2 must be related to 3, 4, and 5. and so on, right? So from here you could conclude that it is easy to see that the transitive closure of R is set of A comma B pairs of natural number such that, well, 0 is related to all number greater to it, 1 is related to all natural numbers greater to it, and so on. So that means A less than B. Yeah. So this is the transitive closure of the relation R. So with this, we conclude the discussion on the transitive closure as well as the discussion on closures of relation. So in the next video, we will talk about equivalence relations, and we will do that in the next video. So let's stop here.